We return to the latest assessment on global climate change. It comes from the UN's Intergovernmental Panel on Climate Change, or IPCC, which last issued a series of reports in 2007. The scientists who wrote it won the Nobel Peace Prize for the warnings they raised and the evidence they presented. The newest work includes more predictions and examples of what's already happening. We take a closer look, starting with this report from Tom Clarke of Independent Television News.
250 scientists, 195 governments and thousands of pages of analysis all conclude the world is warming. Not just the atmosphere, the oceans too. And only a rapid reduction in greenhouse gas emissions has any real chance of turning back the tide.
Human influence on the climate system is clear. Climate change challenges the two primary resources of humans and ecosystems: land and water.
This 6-yearly update of the science concludes temperatures have risen by almost a degree over the past century. It is extremely likely that global warming seen since 1950 is man-made. It predicts global average temperatures are likely to rise between 1.5 and 4.5 degrees by 2100. And sea levels, says the IPCC, have been rising faster since Victorian times than at any point in the last 2 millennia. Time travel down Isambard Kingdom Brunel's Great Western Main Line, and you can see why that's important. This seawall was built to protect the railway from a 1-in-100-year storm event. Now, since Victorian times, when the railway was built, sea level's already risen by about 19 centimetres. Based on today's IPCC report, the sea's going to come up by an additional 26 to 82 centimetres. That means by 2100, what is today a 1-in-100-year storm will be an annual occurrence. The report also gives short shrift to an observed lack of land surface temperature increases since a very hot year in 1998. Sceptical observers claim that shows global warming has stopped.
Well, first of all, it's important to understand what's been happening. So temperatures are still at record levels. Each of the last 3 decades have been successively warmer. And it's that longer-term trend which is important for whether or not we're changing our climate. And the overwhelming evidence is that we are.
Not everything is more certain. This report concludes the impact of warming on extreme weather, like hurricanes and floods, is less clear than researchers previously thought. As best as the facts can be established, this report lays them down, and they should be viewed, say scientists, in the knowledge that since their last report in 2007, we've pumped 200 billion more tonnes of CO2 into the atmosphere.
And a note of clarification about Tom Clarke's story. It explained the potential rise in temperature when measured with the Celsius scale. Using the Fahrenheit metric, the panel said temperatures could rise by 2.7 to 8.1 degrees. Ray Suarez picks up on those warnings and others.
And for that, I'm joined by a member of the IPCC panel, Michael Oppenheimer. He's a professor of geosciences and international affairs at Princeton University. Professor, welcome to the program.
Glad to be here, Ray.
What is the major difference, the major refinement in this latest report from the one that precedes it?
There are 3 new high-level messages. One, it's now stated as extremely likely that most of the warming of the past 60 years is due to human activity. And that's very unusual for scientists with a complex problem like this to state something with such a high level of certainty. Secondly, the projections of sea level rise in particular are about 50% higher than in the last report. That's because we have a better grip on what the big ice sheets in Greenland and Antarctica are going to do. And that's a very troubling development because, as we saw in Hurricane Sandy and other coastal storms, the combination of intense storms with an unusually high sea level causes an extra level, a tremendous level of flooding inland, and is very destructive. And the third message is that the window of opportunity to avoid a dangerous warming, which has been labeled by the governments as a warming of a little short of 4 degrees Fahrenheit, that window is closing rapidly. And we could, by short of the middle of this century, say sometime between 2040 and 2050, emit so much of these gases if we don't change our course that this dangerous warming, where the risks just pile up and adaptation becomes very difficult and in some cases impossible, that kind of warming will be inevitable.
When you move in the space of one report from calling something very likely to extremely likely, these are terms that people use regularly in their daily lives. But do they have, when you say them and people like you say them, something more like scientific precision? Is it more than nuance to go from very likely to extremely likely?
These terms are used with great precision. They are defined very carefully in the report. So that very likely means better than a 90% chance, and extremely likely means better than a 95% chance. And so this isn't casual language. This means the scientists looked at the problem carefully and decided that the case is ironclad. And that's all up and down this issue. There's a big central focus on this issue on many facts, that the Earth is warming, that the warming will continue, that the dangerous warming is coming close, and that if we don't do something about emissions, we'll be there pretty soon. All of that is now known with there's a consensus about all of that. Scientists are very careful. Scientists tend to be skeptical, of course, and here we have thousands of them getting together and being able to agree on this high level of certainty. There is no environmental problem that's characterized by that level of certainty.
You're constantly getting new data in from around the planet. Have you got any new information that caused the IPCC as a body to back off from earlier predictions of effects down the road? Or is everything being reinforced, that the predictions that were made in earlier reports?
No, there are certain things that we think we're a little less certain about, or that where we've lowered the projection. For instance, the climate sensitivity, as it's called, the response of the atmosphere when CO2 doubles, it had a range in the last report of about 2 to 4.5 degrees Celsius. In Fahrenheit, you can about double those numbers. The bottom limit on that range has been dropped a little bit. So it's conceivable with a doubling, instead of a warming of about 2 degrees Celsius, we'll have 1.5 degrees, which is about 3 degrees Fahrenheit. But on the other hand, in the report previous to the last one, the number that was used was the same as it is now. So that shows you that scientists are forever fine-tuning and try to incorporate new knowledge. Scientists are obsessed with getting the answer right, with staying up to date. And if the answers lead us in a direction of thinking we're less certain, or the effects aren't going to be quite as bad, we're going to say that too.
Some scientists and academics cast a more skeptical eye on the work of the IPCC. Among them is Roger Pielke, who's a professor of environmental studies at the University of Colorado. And looking over the latest report, he says the IPCC's dismissal of the significance of the recent hiatus in global temperatures is sure to be seen by its critics as a dodge. The IPCC would have been better served by taking on this issue more directly. And on the topic of carbon emissions, progress on that front will have to come in the context of some well-established certainties, many more fundamental uncertainties, and a good bit of ignorance about what we don't yet know. What's your response?
Well, Roger's completely wrong about the so-called hiatus. That is, the scientists looked at it very carefully. There's an extensive discussion of it in the detailed background documents, which will be made public on Monday.
But hasn't there been a pause in the rise in surface land temperatures?
There's been a slowdown. It hasn't stopped. The warming rate has been slower over the last 15 years than the long-term trend. And that is believed to be because the climate is quite variable. If you look at the long-term record, there are bumps upward, there are bumps downward, and there are plateaus like this one. After every bump downward or every plateau, the climate change then accelerates again. Now, we can't be sure that's going to happen, but it's a good bet. The leading explanation of this is that heat tends to hide in the ocean sometimes. But when heat hides in the ocean, it later comes out and reappears in the atmosphere, and the warming resumes faster than before. We don't know this for certain. We'll find out over the next few years. But it's wrong to say that the IPCC didn't look at it carefully. It certainly did.
What about sea ice? Recently, critics have made much of the fact that there was a measured increase in the amount of sea ice from year to year in the past few years.
There's no question at all that the long-term trend for Arctic sea ice is down, down, down. But just like with the temperature trend, it's variable. The wind circulation patterns, ocean circulation patterns will change the amount of ice in any given year, so you see bumps in the record. There was an extreme bump in the downward direction the year before, and now this year, the amount of sea ice has increased, and over the long term, those bumps average out. But what they average out to is not zero. They average out to a long-term downward trend, which is expected to make the Arctic ice-free in summer by the later part of this century. And that is a startling trend. All in the course of a few decades, we're losing the Arctic ice pack.
Michael Oppenheimer is one of the scientists who contributes to the reports of the IPCC. Professor, thanks for joining us.
Thanks for having me here.